Right off the bat, this is just my theory of gravitation, and I wouldn't even call it a theory. Most of it is more of a re-imaging of the theories we already have. And an added note after the fact, recently as I explored and wrote this script, I stumbled across something very similar. To the point, this might actually already be out there, but this existing theory I stumbled upon only covered a small amount of ground. If there is more out there, there probably is, but at this stage I'm unaware of it. So I'm persisting as if it's my own idea that nobody else has thought of, because I like living in my own delusional fantasy world. And on top of that, I want to share it anyway. At the very least, what I offer is a different visual representation of gravitation that can help someone picture both Newtonian and Einstein's theories in a more intuitive way. And on an optimistic mode, there might actually be something there. I apologise in advance for all my ramblings. I'm going to try and keep this tight, but I tend to get distracted. So let's start. My hypothesis. Point 1. Postulate that mass is a vibration of space-time, like a knotting or a twist. Each point of mass pulls a small fraction of space in towards itself. Point 2. On larger scales, the cumulative effect of this knotting twisting creates a density of space. The presence of mass creates a denser region of space around it. Point 3. Therefore, space-time isn't curving, like in relativity, nor are two bodies physically attracted to each other, like in Newtonian mechanics, but is a density within the space field itself. Picture something similar to magnetic field strength, but instead we're dealing with something more like the thickness of space itself, which impacts on objects within. There are probably more points of this hypothesis that I'll add on later on. So there are other possibilities, so I'll list them too, but could probably be ignored. Point 4 possibility. The quantum level. The pulling of space into knots, twists, causes a force-like pressure. Space is in a heightened energy state and wants to return to its lower energy, unstretched space. And point 5. Phantom particles are made from the natural vibrations of space-time. So in summary, I plan to explore how this idea can work for classical Newtonian and general relativity. And not just that, it can also be used to visualize special relativity, and I have some thoughts on how that can look on the quantum scale. I realize this idea is probably super dodgy and not worth a real physicist's time, and that it will most likely fall apart under scrutiny and on the mathematical level. My logical thoughts could be flawed, or my original understanding of some physics could be wrong, or the mathematics that does match the theory falls short for observational reality. And I accept that one thing could possibly have the whole idea crumble in upon itself, but it's been fun to ponder nonetheless, and over the years I've learned that conceptually it fits well enough in places that it makes it worth sharing. And a final note, this is just a thought hypothesis. I lack the mathematical skills to even attempt to test it, so take it as you will. I've tried to follow logical conclusions, but if we've learned one thing from studying physics, and that is it's not always logical. Okay. So on to my hypothesis on the quantum level. Even though this is just a purely hypothetical concept that I developed from earlier ponderings concerning orbits and relativity, it does provide a foundation that everything else builds upon. So basically I came up with the large scale stuff first before pondering how that might look on the quantum scale. Everything, this whole crazy idea centers around the behavior of the space-time field. And that field is something that permeates all space. It sets the limit on everything. The electromagnetic spectrum is the propagation within this field, revealing the uttermost top velocity that can be achieved. We know that all matter is energy. That's where we get the famous E equals mc squared equation. The mass times the speed of light squared. But what is that mass? Matter as we know it is made up mostly of empty space, with the largest concentration at its core. But we don't actually understand everything about it. Mostly we just know how it behaves. The less mass a particle has, the more complex its behavior, where it looks and behaves like both a physical point object and a wave, and the observation of this particle then influences that behavior. They are weird and mysterious, just like Tom Waits' music. Pondering on this, I see mass as a vibration of the space-time field, just like light is, but the difference is that it has somehow got caught up in itself. So instead of propagating through the field at sea like a photon does, it's twisting in on itself. I'm not sure how this would behave or look, but I usually picture it as a knot in the gravitational field, or some kind of stable corkscrew-like vortex, or a harmonic resonance. For the purpose of this video, I just think of it as a weird twisting bound vibration of the fabric of space that can't untwist, or has a probability decay associated with unraveling. So this means each fundamental particle is a kind of knot or bound vibration in the fabric of space. Side note, this led to my first discovery of how limited my humble bachelor degree was. Read and understand, this is the basis of quantum field theory, that everything is made up from vibrations. If there is more to that, it's beyond me, and undoubtedly, as with all things of physics, there probably is more to it than that, and us mere mortals get the dumbed down version. So what I'm suggesting, and probably already is a thing, is that these knots or twists are in the fabric of space itself, and that's what makes mass. If you want a better visualization of that, picture a piece of string, measure its length, and then knot it. When you measure that length of string again, it no longer covers the same distance as when it was untwisted. It is slightly shorter. That string is still ultimately the same length, but the twist within has shortened its distance within space. This is what I'm proposing what happens to space-time. Each point of mass is in fact the twisting, knotting, harmonic vibration of that space. If we go back to the string, one knot won't make much of a difference in the measured length of space. It might not even be measurable at all to the naked eye, depending on how long we make the string. But if we keep putting knots in it, then we get an accumulative effect. That string becomes shorter and shorter. Side note, I have moved into a slight variation to this where space isn't shortened but stretched. But for the sake of keeping things simple, I'll stick to how I'm showing it now and then move to the other variation later on when that becomes more relevant. Okay, let's move into the macroverse. Can you see where I'm going with this? With 1 point mass, we see the tiniest shortening of space-time, so small that it's inconsequential. But if we add more mass, that shortening increases, and it keeps increasing as mass is added. All those countless knots of matter pulling space adds up, and this creates a density of space. That field, that should be a flat line, is stronger where mass is concentrated, thus our effects of gravitation. We can now look at it as the density of space-time. So, space would be denser where there is more mass, and that density would peak at the mass's core and decrease as one moves away from it. So if we imagine it visually, we have this very simple representation graph of a large mass. Could be anything, but let's pretend it's a sun or a planet, and the gravitational density it exerts around it. The bell curve represents the density versus distance, the x-axis being the distance with the red mass being the point of interest, and the y-axis being the space-time density. This space density then creates a potential energy around it, shown in green. So our theoretical red mass in the middle has a lot of potential energy in the sphere of influence, a potential gravitational energy one could say. An important note with this space density is it's in a heightened state. This density has caused the space-time around it to stretch due to the matter knots pulling it inwards. But this act is like a spring, and the space-time wants to return to its normal state. Because of this, there is a gravitational pressure build-up where the space-time density exists. Space-time is trying to return to its neutral low energy state due to the conservation of energy. I'm going to step back a bit and propose a question. And that question is, what exactly is the gravitational constant? I don't think anyone has ever explained exactly what it is, and I can't find anything on the internet. People say it's just a constant, but constants come from somewhere. They mean something. The gravitational constant is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And if we look at the units, we have this. So here's the notation. N is the unit of force. It's called the Newton. It means the amount of force required to shift a 1 kilo object 1 meter per second squared. If we switch the N with its fundamental units, we expand G to this. If you're not aware about units, this is the same as what we just had. It's just expanded out. The N really just makes things look neater. We can then add them together or cancel them out and give us the most basic units. Our re-imaged units are now meters cubed per kilogram and per second squared. So we've broken the units down again. What are these units? Well, the second is easy. It's the time factor, taken from the Newtonian part. The first part, though, is interesting. This is the unit for density, but reversed. Applying the time factor implies this is a force-like state that is constantly exerted on space-time. So basically this looks like anti-pressure in three-dimensional space. But what on earth is anti-pressure? Is that even possible? I guess instead of a force pushing perpendicular against an object, like in the traditional definition, it is an opposing force. But if we look at it from space-time perspective, it just looks like normal pressure. But if that's the case, why would a space exert this seemingly opposite pressure at all? Well, if the gravitational field lines are stretched, then it's a given they'd rather be unstretched. And given every reaction has an equal and opposite reaction, that would suggest there is an opposite force trying to stop that stretching in the first place. The space-time field is exerting pressure in the normal sense of the word. This would appear like anti-pressure from our perspective, but is like normal pressure from the gravitational field perspective. So the field is being stretched out due to the twisted knots within it. The inward anti-pressure is trying to bring it back in. Writing this does make it sound very similar to Hooke's law as well. And so that's what I think G is. It's the elasticity of space trying to return to normal.